Okay, assessment of AV performance. In this final example, we will be showing three videos first. Here we see the orange vehicle is the ego vehicle, and the blue vehicle is braking harshly as it sees the cyclist on the roadside. And what happens is the ego vehicle also braking harshly, and as you can see in this first case, it is using all the space there is between itself and the vehicle in front, and gets very, very close to the edge. Now, in this case, yes, there was no crash, but is this really a desirable performance? Is this the performance we want to see from an AV? Because the issue is with any sort of a loss of friction in that surface, in that sort of behavior, it can easily end up with an incident. And also getting that close to the vehicle in front, perhaps not the most comfortable of feelings for the passengers on board. Now, the next extreme of this is again the same beginning scenario, but this time our vehicle brakes very harshly, perhaps unnecessarily harshly, the moment it sees the vehicle in front braking. Now, yes, this time there is less likelihood of impacting the vehicle in front, but perhaps again not the most comfortable experience for people on board of this vehicle, and also it actually increases perhaps the likelihood of a rear end shunt by a vehicle following our ego vehicle. So perhaps this is not the most desirable performance either. And let's look at something between both, and perhaps a more optimal performance where the vehicle uses the space it has and the braking power in the optimum way, so that there is a minimum distance kept, and also it's not the most harshest event for the passengers on board. What I'm trying to show with this is crash, no crash is not enough to be able to say yes, this is an acceptable performance, or no, it is not an acceptable performance. In fact, it's much more complicated than that. So we try to explore these concepts by developing our simple assessment methodology through Streetwise, which needs to be and will have to be improved much further in the follow-up development. So what we have done, let's look into that one. Going back to our ego vehicle, we have defined spaces around the vehicle. For example, the red one defines the unavoidable collision zone. Whenever there is an object or another road user within this zone, it means basically the vehicle is too fast to be able to avoid a collision, stop before having a collision in this zone. The orange describes the avoidable but harsh braking zone, which means yes, the vehicle could have, vehicle can stop in time by avoiding collision, but it's not the most pleasant experience, and also still the risk of rear end shunt from behind is there. And green defines the safe distance, which means we have enough space to slow down without any harsh deceleration. Now, in this example, we used a very simple rectangle to prove a concept, but in reality this is not going to be just a rectangle. It will be a much more complex shape depending on the steering angle and the speed of the vehicle, and perhaps it will be even based on a cross-section of the trajectories of multiple road users on the road all the time. And what we also developed is we developed something called a reward function to be able to assess the performance, which is basically a cumulative scoring system based on the speed, acceleration, and crash no crash criteria. So every second, every time step of this assessment, these values are calculated, and we can also introduce a fail threshold. So if the vehicle accumulates any points above this fail threshold, we say the performance is not acceptable for this specific scenario. So at this first step, we can see the speed is fine, the vehicle is obeying the rules. The acceleration is fine, the vehicle is not hard decelerating or accelerating, and there is no crash. So all of the penalty points are 0. And you can see as the vehicle moves, these defined spaces also move with the speed and acceleration of the vehicle. And time step 2, again, everything is fine, no penalty points. And in the simple case, at time step 3, we see the pedestrian jumping into the harsh deceleration zone, and vehicle slams the brakes and accumulates 1 penalty point, but it's not in the fail threshold. Now, if we go from this into the much more complicated scenario from the rate's previous zone, again we start with no penalty points, What happens this time is the vehicle does not see the pedestrian, and again pedestrian jumps right into the unavoidable collision zone. And at this point, the vehicle slams the brake, gets a penalty point for harsh deceleration, and then obviously because the collision was not avoidable, it it earns another point for the collision, which for this case let's say we set up the fail threshold to be 2. Now the discussion to be made here is, was this collision avoidable? Was there in any way this vehicle could have stopped physically without hitting this pedestrian? And in the real world, not every situation will be like this. Some will be unavoidable due to physical circumstances of the incidents, which means fail or again crash or no crash does not necessarily mean fail. So the threshold we set for this example not necessarily should be 2, maybe it will be 3. Maybe what we need to look at here is, will the vehicle perform better than a human would have given the circumstances? And this is very important to make sure we get right. But perhaps maybe I was wrong from all along. Maybe this is a completely wrong approach. Maybe what should have happened is vehicle should have started decelerating the moment it saw the obstacle in the shape of the bus in this junction. So perhaps in time step 2, it should have got a penalty point for going too high, for too fast for the conditions, because if it slowed down reacting to the obstacle, and believe me, this will be a common issue for vehicles around this area where there are parked cars. Vehicles will have to adapt their behavior for this type of situation. Then it would have been slow enough at this point. The red box would have been much narrower, and actually the vehicle, the impact could have been avoided due to the lower speed. So perhaps maybe comparing it with the human setup from the start is not a good point. Maybe what we should have done is we should have rated it against the performance we want to see from these vehicles in expecting the types of incident that can happen to them. So to wrap it up, using this sort of approach, what we have done is we started again with the simulated scenario coming from Carla, and for each scenario simulated, each iteration, we have a simulation data recorded on which we apply the reward function for each time step, and then at the end of each simulation run we have a cumulative penalty score. And then what we do is we run this however many iteration is deemed acceptable for this specific type of scenario, and then we end up with a total score which needs to be assessed to give a performance rating for the AV. Now the scenarios can change, the number of iterations can change, but what we expect is to be something of this nature. And finally, going back through all of the things that I said today, to sum it up, we started with SAS 19 Great Britain level statistics. We put them into our priori dashboard to identify the cases, the impact incident scenarios that are most relevant and most common. And we chose those scenarios, and we enhanced those scenarios in terms of data by matching them with similar rates cases. And then we described these cases using the scenario runner, and brought those into the simulation environment which we developed. And also using the actor maneuver, we controlled all the actors in the simulation for that specific scenario. Now these scenarios are then fed into the simulation, in which we have sensory outputs coming from the simulation into our AV model, and then driving input going back into the simulation to control the vehicle in the environment. Then data is recorded for each time step of the simulation, which is then fed into the reward function, which calculates the number of points gathered, penalty points, and then a cumulative score is collected, calculated for that specific case. And then we are running this loop however many iterations are needed, maybe thousands of times, which is then fed into a final evaluation report. So this kind of summarizes what we've done so far. Thank you for listening.